Hey, can you solve this maths Olympiad exam question? You're required to find the value of 5 to the power of x minus y plus 5 to the power of y minus x. Now, considering all the expressions you know in indices and exponent rules, I want us to see how we can use that in solving this question. Now, to solve this question, first of all, I'm going to assume this to be expression 1, and I'll assume this to be expression 2. Now, what do? We have assumed these two. Let's consider the second expression, expression 2. From expression 2, we can find out that we have 5 to the power of x plus 5 to the power of y equal to 10. Then how about if we take the square of this expression? Then we might be making a headway somewhere. Now, if I take the square of this expression, I can be able to compare it to an algebraic formula. Now, if you can recall this, a plus b square can be equal to a square plus b square plus 2ab, right? Now, from that expression, you come to see that 5 to the power of x plus 5 to the power of y square can be expressed as this. So from that expression, I can have that expression to now give me 5 to the power of x all squared, right? Representing a square plus 5 to the power of y all squared, representing b squared, plus 2 multiplied by 5 to the power of x multiplied by 5 to the power of y, and this whole expression will be equal to 100. Great, because 10 to the power of 2 is 100. Now, from this expression, what will I do? The law of indices permits me to use some certain laws, and this is going to give me 5 to the power of 2x because the exponent will have to multiply plus 5 to the power of 2y, exponent will multiply plus 2 multiplied by 5 to the power of x plus y. The exponent have to add common base, and then we'll have this to be equal to 100. Great. Now, from this expression, I can reduce further. Before I reduce further, I want you to look at this expression. The first expression, equation 1, we are given 5 to the power of x plus y to be equal to 20. Now, did we see x plus y here? 5 to the power of x plus y? Yes, we did. And this is it. So that means that expression can be equal to 20. So we'll have our 5 to the power of 2x plus 5 to the power of 2y plus 2 multiplied by 20, and this will be equal to 100. So if I have 5 to the power of 2x plus 5 to the power of 2y plus this becomes 40, and all of this will be equal to 100. Great. Now if I turn out this, I'm going to have 5 to the power of 2x plus 5 to the power of 2y, and this will be equal to 60 if I subtract 40 from both sides. Now, considering this expression, I'm going to take this as equation what? 3. We're going to come back to this expression. Now, let's go back to the expression we are asked to look for. We are asked to look for 5 to the power of x minus y plus 5 to the power of y minus y, right? So let's look at that expression. If we look at that expression, we have 5 to the power of x plus y plus 5 to the power of y minus x, and say this gives us what? Considering that expression, I want to apply the laws of indices. If I apply the laws of indices here, I can break this to give me 5 to the power of x, right? Remember, this is going to be negative, right? The first expression is 5 to the power of x minus y, so it's not positive. This is negative. Sorry about that. This is negative. So we have 5 to the power of x, and this will be divided by 5 to the power of y, and this will be plus 5 to the power of y divided by 5 to the power of x, and this whole expression will give us what? Now, if you simplify this expression, I want to look at taking the common factor of this expression. We'll have to divide this by 5 to the power of y multiplied by 5 to the power of x. They are common. Divide this whole expression by 5 to the power of y. We're going to have 5 to the power of x, right? Multiplying 5 to the power of x, and this will be plus this whole thing divided by 5 to the power of x. We'll have 5 to the power of y multiplying 5 to the power of y, and all of this will be equal to what? Now, if you simplify that expression, 5 to the power of x multiplied by 5 to the power of y, remember, we'll have to add the index, and for add the index, we'll have 5 to the power of 2x plus 5 to the power of 2y, and this will be divided by this multiplied by this. If we apply the law of indices, common base 5, we'll have y plus what? Y plus x. That's the multiplication law of what? Of indices, and this will give us what? Now let's compare this expression with what we have. Remember what we got in equation 3, 5 to the power of 2x plus 5 to the power of 2y is equal to 60. Now remember the first expression that was given to us, 5 to the power of x plus y is equal to 20. So if we can apply that here, you see that this expression, our answer will just pop out. So this expression will give us, this is going to give us 60 divided by 20. And 60 divided by 20, if 0 cancel out 0, we'll be left with 6 divided by 2, and 6 divided by 2 is equal to 3. So that means the value of that expression given to us up there, which is 5 to the power of x minus y plus 5 to the power of y minus x, will simply be equal to 3. And that is the solution to this math problem given to us up here. That's all. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Thanks so much for watching, and bye bye for now.